Hi guys, I'm going to continue from the same point where I left in for the second video. Afterwards, I'm going to continue. Guys, I was telling you that there is a term called AR and there is a term called MR. We have just discussed that as well, and I have told you already that 1 mole of every substance will have a specific number of particles which is equal to Avogadro's constant. That specific number is called Avogadro's constant, which is 6.02 into 10 raised to the power 23. Here I have few more questions related to that. You can check this thing right now. I'm going to spotlight it right now. How many particles of oxygen in 1 mole of carbon dioxide? Okay, so 1 mole of carbon dioxide will have how many particles of carbon dioxide? That will be molecules of carbon dioxide, and that will be 6.02 into 10 raised to the power 23. As the formula is CO2, which is telling you that it will have 1 mole of carbon. So that's why we can say that how many particles of carbon will be there. So it is 6.02 into 10 raised to the power 23. Okay. If we are talking about oxygen, there are two times oxygen present. So we can say this thing that 2 moles of oxygen are there. That's why we are going to multiply for oxygen 2 into 10 raised to the power 2 into 6.02 into 10 raised to the power 23. So that number, which is called Avogadro's constant, will be multiplied by 2 to calculate the number of times oxygen present, number of moles of oxygen present in that 1 mole of carbon dioxide, number of particles of oxygen, number of moles of particles of oxygen present in 1 mole of carbon dioxide. You may say it like this as well. Here I am going to solve the same type of the question with another example. Look at this example. This is like 2 moles of ammonia. Okay, 2 moles of ammonia. It means that we are going to write it like this. Here I am writing with the blue color. Okay, so it is 2NH3. Okay, we can say this thing that in this 2NH3 there are 2 times nitrogen present and 6 times hydrogen present. So again and again the same thing is getting proved that students must know the formula, students must know the balanced chemical equation, otherwise it will be a problem for them to solve the rest of the concepts, okay, specifically moles and etc. Okay, so when we are writing these 2 moles of ammonia, we can say this thing that number of particles of nitrogen will be with like 6.02 into 10 raised to the power 23, which is the Avogadro's constant. It is now being multiplied with 2 to calculate this nitrogen, and the answer is 1.204 into 10 raised to the power 24. Guys, you must have seen that 10 raised to the power thing at the bottom of your calculator, that with the answer it is written, it is 0 and then point and then times 10 raised to the power x type of thing can be there, and it is available at the top as well. So there are different types from which you can go towards the power. Okay, then it is number of particles of hydrogen. For example, if examiner is asking for this, then you can check this thing that it is 2 moles. When we are writing this 2, it is telling you that 6 times hydrogen is present. We are going to multiply this 6.02 into 10 raised to the power 23 figure with 6 to calculate this. You can check this thing that a bigger number is there right now. Okay, now, so in the periodic table, all masses are for 1 mole. We have just discussed the same point when we were discussing in second video, that molar mass is basically the mass of 1 mole of a substance. So molar mass can be molar mass for a hydrogen atom will be 1, molar mass for hydrogen molecule will be 2, molar mass for ammonia NH3 is 17, molar mass for carbon dioxide is 44. So it is just a practice. When students are practicing lots of the questions related to moles, things will become much clearer and easier as well. Okay, now we are on a very important type of concept. I must say this thing that it is moles to mass calculation. Examiner can ask you to calculate mass from these moles, to calculate moles from this mass, etc., etc. So such type of interconversions can be asked in the moles concept. Okay, what will be the mass of for 1.8 moles of nitric acid? HNO3 is nitric acid. Okay, so MR will be calculated from the periodic table that I have written very clearly over here. Now, when I have looked into hydrogen, it was 1, nitrogen was 14, oxygen is 16, that I have multiplied by 3 because formula is telling that in nitric acid 3 times oxygen is present. So the total mass of nitric acid will become 63. I can say this thing that 1.8 moles of nitric acid will become H. So it will be simple. 1 mole of nitric acid is 63 and 1.8 moles of nitric acid will become X. I have just multiplied the thing and the answer is 113.4 grams. Okay, so in this way we have calculated the mass for these many moles of nitric acid. Here I am on another question. Okay, Guys, mold is basically based upon practice, practice, and practice. More practice you will make, more concepts will be clear, and the things will become easier for you. What is the mass for 2.4 moles of K2Cr2O7? We can say this thing that 1 mole of K2Cr2O7 is equal to 294. How I know this thing? I have just looked into the periodic table, and I am going to share that periodic table with you people right now again. Okay, fortunately, it is on the very next page. Okay, so we can check this thing that chromium is 52. Look at here right now. Chromium is 52, whereas K is 39 and oxygen is 16. You can check this thing right now. Okay, when I am going back there, you can see this thing that I am going to multiply 39 with 2 because potassium is for 2 times. For chromium, 52 will be multiplied by 2 as well, as chromium is for 2 times as well, and oxygen is 7 times. It means that 16 multiplied by 7 as well. I'm remembering that joke which many of my students were cracking in the class as well. They used to call K2Cr2O7 as CR7. So it's up to you how you are going to keep that in your mind. Okay. So I was telling you that in this way, we are just saying that K2Cr2O7 has a mass of like 294. So 1 mole of K2Cr2O7 is equal to 294. 2.44 moles of K2Cr2O7 will become X. Now you are going to multiply this as a cross multiplication. The answer will become 705, 705.6. Okay. Now how to calculate the MR value from the given AR value? Okay. This is a simple concept, although I am explaining it, and we have just practiced this for in few of the questions. But I have observed this thing that sometimes students are missing very simple type of the concepts, and which is creating a bigger issue for them. So, how to calculate the MR value from the given periodic table? Okay. Now look at water. Okay, okay. Now look at water. I can say this thing that in water there are two types. There are two times hydrogen atoms. So it is one and one plus 1 times 16, that is the oxygen atom is 1 time present, so we are going to add this, and as a result the MR value for water will become 18. Okay, you are going to look into the periodic table. You are never going to suppose this thing that hydrogen, oh, teacher told us about hydrogen that deuterium is one of the isotope of hydrogen, so here I am going to take the mass of hydrogen as 2. No, no, please don't take any values on your own. Just look into the periodic table and calculate the relative molecular masses from the given information. Okay, so this will be the periodic table. I have zoomed in the previous video as well and just told it to you that this is the latest periodic table which will be given to GCE and IGCSE, all of the students. Okay, right now I am just saying you that KMNO4 is telling you that K is 39, Mn is 55, and O is 16 times 4. What is Mn? It is not magnesium, it is manganese. So magnesium is Mg and manganese in Mn. Please be careful about these differences. Okay. Then I am on the next concept. Next concept means I'm practicing the same thing for the next question, next example. It is CuSO4.5H2O. What is that dot thingy? It was the water of crystallization. So when compound is being formed, the compound is in the process of formation. Some of the water molecules are just adjusted with copper sulfate or with that compound, and those water molecules are called water of crystallization. We can say this thing that 5 water molecules are just adjusted with copper sulfate in this compound. There are certain examples that Na2CO3 and COCl2 and FeSO4. These all examples are written over there as well. Do we need to memorize these number of water molecules? No, there is no need to memorize that specific number of water molecules. How many number of water molecules are adjusted with a compound? It is not compulsion. It is not our compulsion to memorize that specific number of water molecules, but a student should have an idea. Student should have an idea that this dot is the representative of water of crystallization. Parallel, students should know this thing that what is water of crystallization and how we can identify those water of crystallization as identification test for water. You should know this thing that when copper sulfate is with water, it is getting blue in the color, and when copper sulfate is without water, it remains white. In the same way, there is a test for cobalt chloride as well. We know this thing that in case of cobalt chloride, we can say this thing when water is not present, it is blue in the color, and when cobalt chloride is with water, it is pink in color. These tests for the water identification and etc. I have taught earlier in the previous videos. You can just Google it. Simply, I will just say you can just write it on YouTube and can find out the answer. Okay. So here, just I'm just explaining for copper sulfate. It is copper like a 64, sulfur 32, and oxygen 16 times 4, whereas water will be 5 times 18, and it is giving you 250. Okay, so in this way we can say this thing that alone copper sulfate is 160, whereas water is 18 times 5, which is 90. So when 160 plus 90 is equal to 250. So we can move on to the next thing. And right now there is a question: how many moles in 500 grams of ethanoic acid? Now they have given you the mass and they are asking for the calculation of moles in 500 grams of ethanoic acid. Okay, what is ethanoic acid? This is one of the organic acid. I have told this thing already in the organic videos, and those students who have not studied organic chemistry in their schools at this stage, they can just recall the examples of organic acids and inorganic acids from the videos of the acid, bases, and salts. Over there, I have told this thing that those acids which have carboxyl group called COOH thingy present as a part of their formula are called as organic acids, whereas those acids which don't have COOH thingy as a part of their formula are considered as inorganic acid. HCl is an example of inorganic acid, whereas ethanoic acid is an example of organic acid. Okay, so MR of organic acid from the periodic table is 60. We can say this thing that when 60 of CH3COOH is present, it is equal to 1 mole, whereas when 500 of CH3COOH is present, it is equal to X, which is cross multiplication, and the answer is 8.33 moles for this question. Okay, so it is simply a cross multiplication, and you can calculate the moles from mass and mass from moles directly. Okay, then, but remember this thing that in further calculations I will ask you that mole is always the center point. You have to come to the moles first and then you can move further. I have solved many of the questions for you in the next videos, inshallah, that I am going to explain to you, inshallah. But right now, currently, I am just taking you from the basic, from the scratch, so that every one of you can be on the same page. Okay. Then here I am on another question. How many moles in 410 grams of copper sulfate 5 water molecules? So here I have to look into the copper sulfate dot 5 water molecules as well. We can say this thing that MR of copper sulfate dot 5 water molecules is 250. We can say this thing that 250 of copper sulfate dot 5 H2O is equal to 1 mole, whereas 410 of copper sulfate dot 5 H2O is equal to 1.64 moles. So we have just cross multiplied and calculate the answer for this. Then I am looking into this, what are the concepts which we have discussed till now. I am on the third video, which is like I guess I have just recorded like 15 minutes video is done already. So in those two videos and this 15 minutes, what we have learned till now, so I am just wrapping up the whole concept so everyone can learn the whole thing exactly. How to calculate the relative molecular mass from the given relative atomic mass in the periodic table, that I have just told you here. This is the thing which I am taking you. Yes, this is the thing. This is the thing. Okay. Then in the next thing, interconversion of number of particles from the given moles and vice versa. From the moles, you can go towards the particles, and from the particles, you can go towards the mole. So, like for example, examiner can ask this thing that if it is like 7.5 into 10 raised to power 23 particles given for one thing, how many moles will be there? You can say this thing that 6.02 into 10 raised to power 23 is equal to 1 mole, and these many particles will become equal to X. So in this way, you can calculate the moles to particles and particles to moles conversion. And then the final interconversion, which we have just studied, is related to mass and mole. From the mass, you can go towards moles, and from the moles, you can come towards mass. Okay. Then I am on this explanation. What is the meaning of the term relative? Who is relative? These are our relatives. These are your relative. No, no, please. These are not about the relative thingy. It is just a comparison. It is just to compare. So, for example, I have told this thing in my first video as well, that here we are not comparing it with like something else out of the world. It is just carbon, which is the most abundantly present solid element in the universe. So we are just taking carbon's mass as a standard, and then we are comparing the rest of the masses with that of the carbon. So as the masses are compared with 1/12 of the carbon 12, so due to this comparison, the term of relative is used. Carbon is selected due to following reason. Here I have told to those students who are just a little more inquisitive, and they are asking that why carbon is standard. So as it is stable and most abundantly and precise measurement was possible, as 6 protons and 6 neutrons are there for carbon 12. Okay, so these are the reason why we have taken this. Although hydrogen is the most abundantly present element, that I have explained already, it is a gas and it is difficult to be under control under a specific type of a pressure. That's why we have taken carbon as a standard. Then it is a stoichiometric calculation. Many of the students are unable to pronounce this word even. I have observed this thing. It is stoichiometric calculation. I'm just pronouncing it again, stoichiometric calculation. So these are basically the calculations which are based upon the balanced chemical equations. Sometimes we are just preparing a brownie in our home and we can say this thing that these many eggs are reacting with this much butter and this much butter is requiring this much sugar to make a balanced type of a recipe, to make that recipe. So you people may consider that recipe as a balanced chemical equation. So as far as a student does not know a balanced chemical equation, I'm really very sorry to say he or she will not be able to understand the stoichiometric calculations as well. So this is my request to all of you to understand, and this is my advice to all of you as well, to understand and to practice the balancing of the chemical equation. I am right now here, and these are the calculations based upon the balanced chemical equation. I can say this thing that it is compulsory to know the balancing of the chemical equation. Now, examiner is saying what will be the mass of water produced from 50 grams of hydrogen. Okay, we can say this thing that balanced chemical equation so of water is H2, like H2 plus O2 H2O. No, this is not balanced chemical equation. We have to write a specific number. It will become 2H2 plus O2 and 2H2O. Now many of the students might be thinking from the first example that examiner can ask very difficult type of the balancing of the equation as well. No, no, no. Examiner is not going to ask very difficult type of the balancing of a chemical equation, but specifically there are certain chemical equations which are necessary to know that we are going to practice in our past papers as well, inshallah. But right now, many of the students are still unable to balance very simple chemical equations as well. So please, they are advised to practice balancing of a chemical equation if they want to score a good grade in chemistry. So here I am just telling you that first of all, we have just written 2H2 plus O2 giving us 2H2O. We can say this thing that 4 grams of hydrogen is giving you 36 grams of water. Now this is the question, how 4 grams of hydrogen is giving you 36 grams of water. Just we look into this, we can say this thing that 1 so it is total of this is 2 into 2 is 4. So 4 grams of hydrogen is giving you 36 of water. As we already know that water has a mass of 18, so it is for 2 times it will become 36. What about oxygen? As examiner is not asking anything related to oxygen, so we have just written oxygen to make the equation balanced. That's it. Nothing else is needed related to oxygen. So we are right now not going to consider oxygen in further calculations. We can say this thing that 4 grams of hydrogen is giving you 36 grams of water. What about the 50 grams of hydrogen? It will give you X. So you're just going to cross multiply and the answer is 450 grams of water. Whatsoever is the answer, that's not our concern. But remember this thing that sometimes the students are taking this cross multiplication so lightly. They are missing a zero, they are missing the point, they are missing 5, they are missing 6, they are missing last digit, they are missing third digit, etc., etc. Things are in the problem then. Okay, so please be careful while calculations. Okay, so here it is always important to calculate the number of moles. So moles formula is there as well, and moles is equal to mass over mr slash ar. So remember this thing to calculate moles first of all, and then we can calculate it like this as well, that that a straight way to calculate that. But examiner is just looking towards the moles. Student has calculated moles or not. So it's such type of calculations, if you are not calculating the moles, will be considered wrong. So that's why I am telling you on the very next page that you need to calculate the moles first of all. So moles is equal to mass over mr slash ar. For obviously for an atom you are going to consider the mr thingy, whereas for more than one atom you are going to consider the mr thingy. So what will be the mass of water produced from 50 grams of hydrogen will be like this. Right now I am just doing this question again, like calculations of moles. So first of all, moles of 50 grams of hydrogen, we can say this thing that 50 divided by 2 is equal to 25 moles. Why we have taken 2? Because hydrogen is H2 here. Okay, so we are just taking like 2 moles of hydrogen is giving you 2 moles of water. We can look into this. 2 moles of hydrogen is giving you 2 moles of this, and 25 moles of hydrogen will give you 25 moles. Okay, because their ratio of moles was similar, that's why the answer is same here. So mass of water, 1 mole of water is equal to 18, 25 moles of water is equal to 25. So the examiner is not asking for the moles, examiner is asking to calculate the mass by calculations of the moles. So first of all, we have calculated the moles, and then from those moles I am just saying that 1 mole is equal to 18, so 25 moles will be equal to 25 times 18, which is equal to 450. You can check this thing, that answer remains same, although we have not calculated the moles in this case and we have calculated the moles in this case. Okay, but remember this thing that examiner is looking into the moles. student has calculated the moles, then a different mark students has not calculated the moles. If examiner is going to give you 1 mark for the calculation of the right answer, that's another thing, but working will be credited 0 in that case. So please, I am telling you again and again, it is really compulsory to look into the moles first. Here we have just calculated the moles of hydrogen first, and then from those moles we have calculated the moles of water, and from those moles of water we have just calculated the mass of water. Okay, now there is question number 5 and 6 are same calculations. I'm just telling about these two. Okay, the same point which I have just explained. One is the calculation of moles, other is without the moles calculation. Mole is compulsory, that I have mentioned very clearly, and I'm going to highlight it as well so that everyone can be really, really very clear about this concept. Okay, so I am now going to record the videos from question number 7 onwards. Okay, inshallah. Thank you very much. Take care of yourself.